I'm going to show how to make a box using a signed distance function in Affinity Photo's Procedural Texture Filter. A signed distance function is a way of creating shapes by looking at the distance from the edge of the shape to all the other points in space. The interior of the shape and the exterior of the shape are of opposite signs, so you can find the edge of the shape by looking at where the mathematical function goes to 0. I based this design on a formula by Inigo Quilez. He has some excellent descriptions of SDF functions on his website, and he also has some videos describing how to make SDF functions, including an SDF box like this one. I'll put a link to his website and videos in the description for this video. An advantage of SDF shapes is if you take, say, a step function to find the edge of this, instead of doing it at 0, you can move away from it and you'll get automatically rounded corners for the SDF function. Another interesting aspect of SDF shapes is that they can apply to higher dimensional shapes rather than just 2D shapes. You can make 3D shapes using them, and you can even go to higher dimensions if you want to. To make the SDF box, I'm going to divide the space into several different regions. First of all, there will be the outside area. That's going to be one sort of set of equations. And then there will be the interior part. That will be another set of equations. And then for the outside part, I'm going to have this section here on the corner where it looks sort of circular. That will be one formula. And the two flat edges will be a separate formula. The other thing I'm going to do is I'm going to just define 1/4 of the box, so just the first quadrant. And then I'll use the absolute function to mirror across the x and the y axes to create the final box. I'm going to start with a new document. I'll start with XGA, but I'll change the height to 1024. Make sure it's in RGB8 mode and create that. I'm going to choose black and fill this with black. I'm going to switch over to the Move tool and then add a Procedural Texture Filter. And I'll start by adding a single equation and assigning it to all 3 channels. And I'll add a single real input A. I'll call that scale. And I'm going to set that to 4. I'll start with a variable v for a coordinate system. That'll be a 2-element vector based on the relative x and relative y pixel locations in the document, and then times a, which is my scaling factor, and divide by w, which is the number of pixels across the width of the document. Now, in shader programming, you might see this called UV, like that, but I usually use just V because in the presets for the Procedural Texture Filter, that's what they used, was just V, so that's what I started using. But if you're watching some other videos on shader programming, you might see them use UV for this. So there's my coordinate system, and you can see that the x coordinate starts here at 0, the origin. That's where I double click. I can move the origin, or I could drag it around with this, but if I double click there, that's the origin. The x coordinate is assigned to the red channel, the y coordinate is assigned to the green channel, and the x starts at 0 here and increases as it moves to the right. The y starts at 0 and increases as it moves down. Now, I'm used to my y coordinate going up, so I'm going to convert this so it does that. So I'm just going to put a minus sign in front of the ry, and so then that'll put this coordinate going up. Now, if I just look at the length of this, I will get what's called the SDF circle. So if I look at just the length of V, it forms sort of a circular shape. It gets darker towards the middle. It's almost like a cone, if you could imagine that. You can see in the scope here, it's very cone shaped. I'll add a step function around this. I'll put an edge on it and apply that to the length. And so if I add a 0 to 1 slider and give it the edge, I'll just call this edge, then I can control the radius or the diameter of the circle with this slider. I'm just going to take that off of here for now. Now I want to make a rectangular shape, and so I want to be able to control the X and Y position of the circle, and this circle is going to form the corner of the rectangle. So let's do that. So I will add, I'm actually going to delete this edge for now. I'm going to add 2 0 to 1 sliders. So I'll call them BX and BY, and this will be the width and the height of the rectangle. That's what those are going to become. I'm going to set them to 0. I'm going to insert another variable, var b, and that will be for the corner of the box, the position of the corner of the box. And that's going to be a vec2, 2-element vector based on bx and by. Now I'm going to insert another variable, var, I'm going to call it d, and this will be sort of the difference between the v, the coordinate vector, and my b value, which is the corner position for my box. And instead of length of v, I'm going to take the length of d. Now I can control the position of the corner. This moves it in X, and then this one will move it in Y. Now I need a way to separate this into 4 different quadrants. In the first quadrant, I want it just to be the original value of D, but in the second quadrant, I want it just to contain the Y component of the vector. And so in that quadrant, the X component is negative, Y is positive. I want to get rid of the negative component. Down here in the third quadrant, both X and Y are negative. I want that just to be 0. And then over here in the fourth quadrant, where the Y component is negative and the X component is positive, I want that to be just the positive X component. Now it turns out that if I just take the max of D compared to vec2 of 0, 0, it will do exactly what I described. So if you look at this, I'm comparing d.x to 0 and d.y to 0. And seeing which is bigger. So anytime one of those components is negative, it will be set to 0. Otherwise, if it's positive, you'll get the original vector back again. I need one more parentheses. Okay, so there it is. I have my corner, and then you can see it's nice and rounded out here. It's square over here. So that is the first part of the box. It's only a quarter of the box. All I need to do is to apply the absolute function to my v value. And that turns it into the rectangle. So just look at what that's doing. I'm going to set up another equation down here. So if I look at my coordinate system, v, and then take the absolute value of that, you can see it mirrors across the x-axis, and then it mirrors across the y-axis. If I subtract v from this, then I get that shape, and then the last step is to take the max of that and then the length of it. Now I could add a step function to this. So if I take a smooth step of E and then E plus S and add a parentheses and then add two more 0 to 1 sliders for E and S. I'll label this one edge and this one smooth. Then I can control the edge of this. So I can get it pretty close to 0. Now, one thing that happens with this is, like all the way to 0, it just winks out of existence. And that's because I haven't taken care of the interior of the box yet. I just set that to 0, didn't do anything else with it. So I need to fix that, but otherwise it looks pretty good. It's making a box. I can change the dimensions of the rectangle with these sliders. Now the last part of this is to take care of the interior of this, so that has to be set to some reasonable values. I want that to look like this and to be 0 outside of this interior region. So on the outside I want it to be set to 0, inside I want it to look like this. So in this portion I want it to have the x component of the vector. In this portion I want it to have the y component. Over here I want it to have the x component. Over here I want it the y component. So whichever one of these is bigger, I want it to have that value. Okay, so let's do that. I'm going to delete this equation. So I'm going to set this up in a separate equation to show what's going on. I'm just going to copy this one, paste it down here. And I'll assign it to all 3 channels. So I want to take the max of d dot x and d dot y to get started. So that looks like that, and it looks like, you know, it's black in the middle, so I'm not sure, is this doing what I want it to do? So I'm going to invert this because those numbers should be negative over there, and when I invert it, it looks, yes, this is exactly what it's supposed to do. It's supposed to look like that. So that looks good. The only issue is when I take off the negative sign, I want this all to be 0. So here where it's negative, I want it to be this function, but out here where it's positive, I want it to be 0. So to do that, I'm going to use the min function, and I'm going to compare this to 0. Now this time, this is not a vector, so I don't have to put my 0 as a vector. That looks like it just all went black, but if I take the negative of this, now I have this as the function that it's supposed to be, except for this. So I'm going to take this function and add it in up here. And I think since this is getting sort of long, I'm actually going to create this into a variable. So I'm going to make a var L equals length of max of d comma vec2 0 comma 0 and plus min of max of d dot x comma d dot y comma 0. And now I'm going to put my step function back in, smooth step of e comma e plus s. I'm going to divide that by 4, and then L. So there's my rectangle, and now I can go all the way down to 0 and make a nice tight box with that. Nice sharp edges. The other thing I could do is I could change this to smoothstepn, which will invert the image. So if I do that, place an N there, now I have a white box on a black background. And so I have my nice SDF box like that. And smooth out the edges a little bit, or if I expand this, I can make the edges rounded. I'm going to delete this equation. So that's my finished function. I just want to explore the positive and negative regions of this a little bit further. So to do that, I'm going to add a 0 to 1 range input. I'll label that I, and this is going to be an offset, and it'll allow me to look at this in the scope. I'll start out with this down at 0 though. And then I'm going to add 2 new equations. I'm going to turn the RGB off on this one and the A off, and set the first one to R, the second one to green. And I'll copy this equation and paste it into both of these. Now for the first one, I'm going to delete everything except for the positive area, which is the length of max d comma vec2 of 0 comma 0. I'm going to add my I for the offset. And then the second one, I'm going to delete everything except for the negative area, which is the min max of d dot x, d dot y comma 0. And I'll delete the smooth step. Okay. And then I'm going to add the offset to that one as well. If I switch over to the RGB waveform in the scope, I can see that this area is green, and that's actually the 0 line. So if I bring the offset down to 0, that will be down to 0, but as I bring that up, it starts coming up. So this is green, that's 0 out here, and then it goes negative, and then it stays at 0. This other one keeps going up indefinitely, but when it gets to 0, it stays at 0. That's why there's a yellow line here, and then it goes up again into the red. So that's how that looks. Now another thing I could do to show those offsets, I'm going to add a real input C. I'm going to call that lines. I'm going to set it to 10. And up here on my equations, I'm going to turn the red and the green off, and I'm going to set the red, green, and blue in my original equation to on, but instead of smooth step, I'm going to replace this with osci, and I'm going to have C times L. And so I have that pattern, and then I could add a gradient map like that. The last thing I wanted to do was to compare Inigo Quilez's pseudocode to our procedural texture code. So on his, he has float SD box in a vec2, and he gives that the letter P. That's the coordinate vector. But I used the letter V instead because that's what I'm used to. And then the second part is an input vec2 of B, and we do that the same way. The inputs, we're using BX and BY as slider inputs on that one. Then For his, he has a vec2 d equals absolute value of p minus b, and we use variable d equals absolute value of v minus b. So almost identical. And then he returns the length of the max of d comma 0 plus the min of the max of d dot x d dot y comma 0. And in our case, the only difference is we have to specify that the 0 is a vector. So we can't just compare it directly. We have to set it as a vector, and then we can do the comparison for the max and the min. And we're not required to put in a decimal point to show that it's a real number. So pretty similar code looking at these two codes and comparing them. I thought they looked quite a bit alike. I'm going to encourage you to look at some of Inigo Quilez's pseudocode for other shapes. He's got quite a few other shapes. I've tried a couple of them. I may show those in a future video. But knowing, how to convert from that code to procedural texture code in Affinity Photo should help you try to decipher how those are working. It may take some experimenting to get them to work, but I have been able to get some of the others to work as well. So that is the finished SDF box. Let me know if you have any comments or questions, and thanks for watching.